Welcome back to AWS Well Architected Solutions on Twitch. I'm Julio, part of the Evangelist team. It's great to be here with you today. Our subject is the application architecture, building with the best practices and patterns that we see in customers and partners, and building this kind of solutions in the cloud with you guys. So let us know what you would like to see, what kind of things you would like to build, and we're going to do that together. So for the past few times, we talked a lot about scalability and getting compute solutions to scale and things like this. Today, I'd like to approach this first part of the well-architected page, this first idea here of building and deploying faster. The idea is how can we change our architectures in a way that it is truly effective. For example, at Amazon, we have the latest number I have is from 2014, and it's something like this. We did 50 million deployments a year, and that on average would be a deployment about every second and a half or so. And you can imagine that by today's rate, that would be quite possibly under a second. And this is at Amazon's production website infrastructure. So how can we make it reliable? How can we change something at that scale, that fast, and keep experimenting with things and keep improving the business for customers and all things that I'm sure you guys see at Amazon. So this is not something specific to Amazon. Different customers and companies like Netflix, Nike, Halo, and many others passed but to the same movement of migrating to microservices, having infrastructure as code, and getting things through the door at every push of code. So that's the kind of thing I'd like to discuss with you guys today. And I'm sure some of you may have built Jenkins server or any other CI/CD solution. And well, that's pretty much the kind of things we are going to do today. So let's jump right into it. And to begin, I'm going to open the Cloud9, the CodeStar interface. You can find all the services that we are going to be talking about today here in the developer tools part of the console here on the AWS management console. And we're going to use all these services today and talk about each of them. So let's start with CodeStar. So CodeStar is a project template service, let's say it like this, a process development, a continuous delivery, all those process improvement things and tools that you may see with all those different names are kind of bundled together into AWS CodeStar. Let me show you guys how it works. It's even easier than explaining. The first thing you have to do is choosing a technology stack here. And this is just a starter point. You don't need to follow or use this as we ship it. This is just so you have a place to start. And here we have all modern languages, lots of frameworks, and different kinds of solutions such as web services, web applications, pages, and on different runtimes on AWS, with Node, with Python, with Java, and so on and so forth. So let's start with a Java web service, for example. So let's pick Java and Spring running on AWS Lambda. And since we're doing Java, let's name this enterprise project, enterprise demo, or something like this, enterprise thing. And our enterprise thing, we can host it on any code repo that we'd like. The options we have here are GitHub and code commit. And being an enterprise project, I probably want to keep it together with my infrastructure, my enterprise data, and not open source perhaps, and just using it on code commit. Because code commit is a Git repo as a service. You can just send your code there as you would with any other code repository. And on GitHub, we would have the open source side of things where you don't pay for users, so you can open and share your project with the world. And let's do just this. Let's use code commit for now. And you can see that CodeStar is going to create all the continuous delivery pipeline for us, from the source to the build, running the tests, running AWS CloudFormation templates to create our stack, and monitor everything with CloudWatch. So let's create that project. So now that the project is created, we have the configuration for the source code. Let's select our choice of tools. And I'd like to talk today about AWS Cloud9. So the IDE is a pretty personal choice, and we are going to be talking a lot about Cloud9. So Cloud9 is a cloud-native IDE where you can launch an IDE on the cloud and use it with any browser, so it doesn't require a laptop. So if this laptop burns on fire, or if I lose it, as I've lost many of those, you can just find a web browser, connect, and you will be on the same breakpoint that you were when you left it. And this is very, very useful. So let me show you guys how this works. And just before we create our Cloud9 environment, I'm going to set up a VPC, set up some security aspect of this, because when I do this, I can select like a big machine, a small machine. You can have your development environment the size that you want. Let me pick a C4X large here. But here on network settings, one thing that we can do is create a VPC. So let's use this to separate our development environment from the rest of the things that I have on this account. So creating your development environment on a separate VPC will help you ensure that if you use a library, for example, if you have a dependency with vulnerability, it doesn't accidentally reach to your data or something like this. So let's start with a dedicated VPC. A simple public VPC should work. I'll name it VPC Twitch, for example. With this public IP, no preference for AZ. This is public, can have host names and the full shared hardware tenancy. So we've got our brand new VPC, and its name is this one finishing with DFE. So let's refresh this and select the VPC DFE that we just created. All right, and environment description and our cost saving settings. So this is what to do when you're not using your environment. So you have to keep in mind that everything in cloud, you only pay for what you use, but you pay for everything that you use. So don't leave your Cloud9 environment running after you go in vacations. Just turn it off. Say after an hour of inactivity, it will just shut down. So when I'm done with this broadcast and everybody's home, I don't need to do anything. It will shut down itself. And that's pretty much all it takes. If we take a look at our Cloud9 CodeStar dashboard, the application details, each part of the app you're building is right here. And again, I'm sorry I can't see some questions right now. I'll take the questions a bit later. technical difficulty here, but I will show you guys each step of the way as we go through it. So here we have the continuous delivery pipeline created in CodePipeline being triggered from the start. So let's just see how does what's actually going on here. What we just created for this enterprise thing. First, we have code, and here in this left side we can access code commit. And in code commit, the project template that was created for us, a simple README file, and all that this application is going to do. For example, we have the POM file for our Maven build, our source, and our Java code should be on source main Java, as you would expect for any Java app. So the usual directory navigation. And here we go. We have a handler and the hello world handler. So this is the code that actually is going to be ran when our application endpoints complete. So it's going to give you a response with exactly this output, hello world. Let's take a look. And well, every time that this changes, we're going to trigger the pipeline. So let's take a look at the pipeline. Here on pipeline details is the following service. So the source is on code commit, and after the source phase is fetched, so this is the pipeline, and the next step is build. So a service called code build is going to be used to generate our deployment files. So here it's already built, and this service works by interpreting the buildspec.xml file. So let's go to another tab of this code and open here the buildspec.yaml. So here on this buildspec.yaml, we have the different build phases. It will run the install commands first, then the pre-builds, then the build, and that's the life cycle, because in the install phase, it's going to be ran only once when your container is started and things like this. So you define exactly what you want to happen in each stage. So the build here is going to echo that the build started on a given date, run a Maven clean compile and build everything. And in the build phase, the commands are just to generate the jar files. And you can separate the things in different phases as appropriate for your app. The important thing is you have the separate points to control the life cycle and when you want each of those steps to be performed. And you also declare here the artifacts. What is the output of your build process? It could be a zip file, it could be any kind of binary that you produce. Here in this example, this AWS CloudFormation package command outputs this templates, this final CloudFormation template, and this is the only artifact here in this case, but you could have many different artifacts and whatever binaries and libraries your specific build suite produces. So let's see how this is progressing. So it was just deployed, and to deploy, we're going to use the recipe you defined in a CloudFormation template. So this is yet another service that will interpret another template file, but this time not for the build, like code build just did, but for the actual runtime infrastructure, the actual compute, the servers, the databases, the backends, everything you declare, CloudFormation will create on AWS for you. So let's open yet another code editor here and show you the template YAML. So this is the template YAML. with the only resource that our architecture will have today, this simple serverless function. It's just a function that will be called when you invocate the get request on the slash resource on this get event API. And this will trigger this specific Java handler class and run with this code. So if this all happened successfully, we should see the application endpoint running right now. So here it is, our simple hello world tag. Let me just take a look at the questions here, and I will, if you have any questions at all, just feel free to ask them on Twitch chat. And this is the most important part of Twitch, is that we are having a conversation here. So I'd like this to go the way you guys think it's important. So if there is any kind of feature that you would like to know, or how to do something you have on your specific development process, I would be glad to help you guys with this on stream. Well, so let's start by this, just a quick overview of the whole development process and how these things connect. Let's go now to the CodeStar and take a look at the Cloud9 development environment that we requested just before we start. So I will close all those tabs that we created and go to the code. When you click not the code, the IDE, sorry. So here's our Cloud9 environment, and the Open IDE button will jump right into the thing. So that's the Cloud9 IDE right there. And you can see that the code, our code, was already checked out for us. So here we have when we associated those things, Cloud9 already made the git commands, get the git pull, and cloned the repo for us, okay? So let's try to make a very simple change and see the build process go through. If I go to that handler file, and again, the good thing about working on a browser is this: if anything happens, I lose this closes on me by any reason, you can just log back in, and you have this brain freeze effect that you get back to your IDE right in the point where it was, with the same commands, with the same terminal open. And let's stop for a moment and consider the difference that this makes when getting new developers. For example, say you just got into a project, you were hired, you can just give the new developer an IDE with all the components tuned in, with database, Docker containers, cache, in-memory caches, whatever you have declared in your infrastructure as code, it's already working from file new. You don't have to do anything else than open a browser, connect to your IDE, and done. And also think about some months later where you've done the project, you're gone, a year went by, and you don't use your project again, and you don't even remember how the thing was, and someone calls you and asks for a change. You can just go back to the point you were when you left it, and it will be right there, right? So this gives you some tremendous possibilities. It's like being able to have as many development environments as you want, and as in the cloud you only pay for what you use. It's no difference at all if you use one or the other. It's going to be actually the same cost. So this is pretty useful. and I use it constantly on my routine. So let's change this hello world and say something like hola mundo, and go to our enterprise thing, git add this, add our handler, commit our code, and push. And well, now that the push is through, you should be able to see the code running here, the dashboard being activated, the pipeline in the source, it's already in progress, and it will go through each step of the build. If there is any problem, for example, if the build fails, it of course wouldn't proceed. If the build is successful, it goes to the deployment, and in a few minutes we should be able to see that live. So that's how it works. And if we'd like to change the components, our architecture, and add not only code but other elements to this thing, for example, to add in more memory caches or add a database or add anything, all we need to do is change this template.yaml file, where you see here this resource called getHelloWorld being a serverless function. This is a CloudFormation element. So if we go to the CloudFormation the documentation here, on the Lambda function, you can see all the properties that you can set for this specific resource. So each of those properties will have a description, if it requires substitutions or interruptions, if you change that property on your template file, the return values that you can fetch from this resource, and a small example of how to use it. And see that this is not only for the function, right? Here on the left side, we have all the different resource types that CloudFormation supports. So if we'd like to add a database, on RDS, this would be a DB instance. And again, just add a piece of code like you see here. So this is how you change your architecture, how you make this kind of experiment and try with infrastructure as code, and everything will be automatically provisioned and created for you. And also using this Cloud Native IDE, using Cloud9 can give you more Cloud Native features on an IDE. For example, this was one way to create a Lambda function. There are many others. Say you want something simpler. I don't want this enterprise thing. Let's do a Lambda function to do something else. Here on AWS resources, on your IDE, this plus, little Lambda plus, will let you create a Lambda function. Say, hola mundo. Only alphanumeric characters. Okay, so all the runtimes and examples that are available here, I'll pick this empty Node.js. It could literally run by any trigger. I will use the API gateway and say that it's on /hello. And in this case, not requiring a key. How much memory am I allowing this function to use? The roles specifying its security, and finish. So if you'd like a more wizard-oriented experience, this is another way to create a Lambda function. And You can run it on your local environment. So if I click here, let's say, and that I want to execute it locally, I can just run and see the result of the execution coming here, and even debug this code with the JavaScript debugging tools if I like. And the remote functions are the deployed versions of this. So I can select this and deploy it to the cloud, and within, oops, it was not created yet. In a few minutes, it will, and we can try to deploy it. And this is the kind of things that Cloud9 makes it possible and very much effective, I'd say. So this is the AWS resources for Lambda. Let's do one more thing with Cloud9, which is sharing this environment. And this is a pretty cool feature, especially if you're using Agile or experience, pair programming, or if your company do peer reviews, or even if you work with people over the internet. And you know that coding with those remote desktop tools can be quite a pain. So Cloud9 has a share here where I can share my environment with my colleagues quite easily. I can just go here to the to my application environment and add any user that I have on my account here as a collaborator. I'll create a new one, and hopefully I can share with you guys a bit later. This is the Twitch username, and I'll add him to the console with a custom password, not require him to log in again to change password. Let me add something here. Let's see what permissions this guy must have. At least we should give him access to Cloud9. So on the security policies, I will put Cloud9, AWS Cloud9 user. That will grant him access to the Cloud9 environments. And that's pretty much it for creating a user. I can go now to the, let me reopen this and add Twitch. And okay, I have shared my environment. Let's get this copied and open in another browser. I will. So nice to see you here, mate. And on Cloud9, I will open another tab. Ooh, I'm not, guess I'm not authorized here. I'm with a different user. So I will sign out. See how secure this is. No user, no rights. You have to change your user, of course. And I'm Julio, my AWS account alias that I will share with you in a few seconds. My AWS username is Twitch. My password is this. And I'm on Cloud9. And let's paste that link again. It even has a VI mode if you're a big fan. And voila, I've got two users on the same IDE. Let's get this window here, and open the README on both ends. Of course, this could be any file at all. Close a bit of these things to the side, and we can. So I can change this, you see, on one side, and this is pretty cool. And the same, sharing is caring, right? So that's how you can share the Cloud9 environments and with as many colleagues as you'd like. If you wanna try that out, this account is, let's do something really dangerous here. This account is bit.ly/JulioAWS. So this will give you my account login link. Yep, user is Twitch, and password is build on AWS. Let's see if anybody can log in here and destroy this text file with me. I promise I have credits for someone doing that successfully. Come on, Hendo, where are you? All right, let's back to the collaborate, and Twitch is offline. Let's wait to see, hey, Twitch is online. Feel free to add it, run, write something. Please don't be, please don't, please be respectful and, well, edit our code at will. Any message? Yay! Collaborating with strangers online live on Twitch. How about that? I hope that's okay with our enterprise security policies. And this is just a temporary account. Don't worry, there is nothing at all there. And will be shut down in a few seconds. That's what I'd like to share with you about Cloud9. So it's a very different approach to development. We can share code, we can be straight in the cloud, we can use this in any environment. We have a dedicated connection. You don't have to worry about who uses which operating system and if the local tools are available and all that hell. So just change your code and go. Yay! That's it. Well, let's see. I will go out of this before it's too late, and let's start to let's see if we covered all we needed. I have to show you guys how to create a separate account in a VPC. I showed you how to create a project in CodeStar, how we stored our code in CodeCommit and GitHub. We created our Cloud9 IDE. We showed how to create functions from the IDE, how it allows you to freeze your brain and save things on the cloud and not have this cold start of developers when they come along. You can just give people an IDE with all the components that are necessary in your dev environment and go from there. And I'd like to show you guys now a different feature of code build, because although everything is nice to have on the cloud, we do sometimes get on airplanes, right? So it may be useful to use to be able to build those things locally. So let's do just that. There is this thing called AWS Code Build Local with local support for code build. You can follow this. This is one way to do it. There is a better one in the docs. So I will just download this script. This is just a simple shell script to build the containers, to run the containers for code build, and it's the same containers you would see on that code build will run for you. Like it's the same results in the end. Let's get the oops. I guess our ID. Is there something wrong with this? Is my environment gone? Did anyone delete it? Let's see. Let's go to the try to open that again. Yep, that's probably gone. Let's revoke that row. Let's be safe for while we can. And well, you only have this row, so it should work. Interesting. Well, the idea is using this code build shell script, it will activate the same container and you can pass the environment variables and everything that you need to run code build, and it will go through the exact same build spec and run the build file for you. And that's it. We did talk about how to create things in code with CloudFormation. We did open the code pipeline. I would just like to add a few things to our pipeline, as that may be important for your development process. Because each development process is different. We require different approvals from different people. So if you like, we can edit and change the process to accommodate anything we want. The code build, the code pipeline processes are defined in terms of stages, like here. So I can add a stage and say this pre-deploy or before live, for example, and add a stage here. Stages can have action groups, and this is my approval group, for example, where I can add manual approval, for example. And the manual approval can have notifications, can have lots of different configurations, or be just a simple manual approval. And you can add as many actions as you'd like to your build. So for example, let's take a look at what kind of things code build can do, the interesting code pipeline can do. So it can trigger a code build, it can trigger Jenkins, it can trigger Solano CI, can deploy with CloudFormation, code deploy, Beanstalk, OpsWorks, ECS, can invoke a Lambda function. So if you'd like code pipeline to do anything that it's not built to do, you can just create your own Lambda function and trigger a Lambda function from here. It can fetch the source code from code commit from S3 or from GitHub. And the testing tools can be on CodeBuild, on Device Farm for mobile devices, on Jenkins, on Blazemeter, Ghost, and all those testing providers. So this is very, very flexible, and you can certainly customize it to do anything you'd like. A very common thing is having the manual approval. So if you have that in your environment, this will just move on to that phase. So when I save it, our pipeline will have a manual group. Unfortunately, our code won't build. We have this. We have probably introduced a bug here. Let's see what's going on. On the details, as that's quite often the case, the build fails. Let's see what went wrong. So you can take a look at each build log and see what went wrong. Even the console part of things is here. So it was executing the Maven run, downloading the whole internet as usual, and let's see where things went wrong. So see, as usual, it's just something silly that the developer did. I expected that changing a silly string wouldn't matter, but it actually broke our build because some developer had a test expecting it to be hello world. So let's change this and see if our code passes. I'll try opening that IDE again. Or else, let's see how it is on code commit. Source main. Oops. On source test Java. Huh. And in our handler test, here is, I can edit, even with the dark theme. And in the expected response value, instead of hello world, we have the hola mundo. And I'll change this to julio.com and fix it test. So let's see this go through our build. On our dashboard, see our source is already in progress. Let's open the pipeline details, and while that source builds, let's see if I can help anyone with some questions. Yeah, yeah, I should have done the test first. Bad TDD guy. Well, let's thank you, Randall. By the way, let's see how it goes. Oh man, and the source. Oh, building. It's Java. You can't expect to be so fast, right? Let's just wait for a bit. It will fetch the source, build the thing, and hopefully in just a while, we'll be able to run our dry run, our manual approval. While that goes on, I'd like to show you a bit more of CloudFormation that people usually do not expect. So take a look at this CloudFormation resource here called Code Pipeline. So if you see that code pipeline and CloudFormation can be created as code, just like your deployment environment and your build environment. This gives you some interesting possibilities of infrastructure as code. So you can, for example, create the build pipeline in several accounts and have the one commit trigger several pipelines everywhere you want to have that code deployed, or even the Cloud9 IDE resource. So even your Cloud9 environment can be created as code. So you can have a bunch of templates and with every project infrastructure, including the IDEs, and just start the whole thing up with one deployment. And that saves a lot of time. And that's how you're able to do a deployment every second if you'd like. Okay? So yeah, still building. Another let's show some CloudFormation resources that not everybody is aware and can help you build this kind of thing. So this code pipeline, the Cloud9, all the developer tools again are here. So you have code build resources, code commit repo, everything that we created now by clicking, we could create by code using templates. CloudFormation is very extensible and composable. If you find anything that CloudFormation can't do, there is a custom resource that can just trigger a Lambda function for you. So if you have external services, for example, if you need to create something on a data provider or on a Twitter API or a Meetup API or anything that you want that is not inherently available in CloudFormation, you can write your Lambda function as usual and bind to a custom resource in CloudFormation. And then CloudFormation can do whatever you'd like. Well, and finally, our code pipeline should be waiting for approval. And this is not going, the code was built, so we have a build success, or else it wouldn't be in this phase. Clicking review would allow you to approve or reject the request, and the same thing could be done through an API call or through any kind of resource like our code or anything that can invoke the CLI or make an API call can just do the same thing that we're going to do now. Say, okay, go and approve. And if the logged in user has the IAM authorization to do this, it's going to be approved and live in just a sec. So one more refresh. Let's wait for the next phase, and soon we should see this built and live. Okay, let's just on the same endpoint. Meanwhile, it's still hello world. And if we take a look at our runtime environment here on CloudFormation, let's see how the stack creation process is happening. So you see everything here is a CloudFormation template. So our Cloud9 environment, our CodeStar project, everything is defined right here as code. And in just a little while, we should see this one of those stacks being updated. So the deployment is in progress on the CloudFormation console. Too many environments here, right? Yep. So found on X, if I can track any changes in pipeline as code in source. Yeah, that's it. That's it. Instead of having to do things by hand and click creates and creates and creates in your web IDE or the pipeline environment, you can just define things as code. That's the. So it succeeded generating the change set, executing the change set. So it does take a while. So that's the thing. It's not, you can't make everything instantly, but you can make it repeatable, reliable. Every change will flow through the exact same process. You get to see the history of what went down in each of those builds, and everything is available for the CLI or for the SDKs, so on and so forth. Our update is going in progress. So this means Lambda is getting the code update with the new function code. Here in the CloudFormation's overview, the CloudFormation console, you can see the outputs of this stack when they're ready. And if you want to take a look at the template that was used, anything on CloudFormation, if you want to reverse engineering a few things, that is quite useful. See how these projects were built, how everything is created. This happens to help a lot. You even learn some little tricks. It's just like the view source on the HTML, but for CloudFormation. So we're probably done. Okay. And by changing this, refreshing this page, we have the Hola Mundo finally. So that's it. You see how easy it is to create some code that we can update from the build tool, from the IDE, the IDE on the cloud, and we can change both the code and the architecture, and CloudFormation is going to keep everything correct for us. And well, that's how particularly I like to build stuff. I hope it shows you some nice tricks, and see you on the next time. That's it for today. And if you'd like to keep in touch and talk more about this kind of thing, I'm Fireman J on Twitter, and feel free to ask questions, suggest new episodes. I'm here to help you guys be successful with AWS. Anything you'd like to build together here on Twitch, just send me a tweet and let's do it. Thank you so much. Bye bye. See you next time.